Good afternoon, class. We are looking at pre-calculus practice quiz number 4, module 4, covering chapters 8 and 9 and section 5.4. Chapter 8, application of trigonometry, polar coordinates and vectors. Chapter 9, system of linear and nonlinear equations. Here's the pledge that I expect everybody to read and follow for the exam. I pledge on my honor that I will neither give nor receive unauthorized assistance during the exam. This is extremely important. I want to make sure you realize when you take the exam, it is as though you're in class, okay? So here's module 4. The first part is about section 5.4, the right triangle trigonometry, and chapter 8, part 1, application of trigonometry, the law of sines, the law of cosines, polar equations. All right, so starting with module 3, chapter 8, part 1, application of trigonometry, we want to find CD, this distance CD, and let's look at what's given. This angle is 90 degrees, so we are dealing with the right triangle, okay? So this is 180 degrees. So therefore, this angle must be 180 minus 36. So if you subtract 36 from 180, you get 144. So the angle ABD must be 144. So again, this entire thing is 180 degrees. So if this is 18 and this is 144, you add them up. (162) subtracted from 180, and this becomes 18 also. So this one is basically 180 minus the sum of 18 and 144, and this becomes 18. Now, if two angles are 18, that means these two sides must be identical. So if this is 200, so is this one. Why is that? So this is 200 also because isosceles triangles properties. 18 degrees, 18 degrees. If this is 200, this must also be 200. Remember, we were interested in finding the distance CD. So if we go into this right triangle, BCD, C is 90 degrees. So sine of 36 is the opposite, which is CD, over the hypotenuse, which is BD, and BD, we know it to be 200. Therefore, CD is the product of 200 and sine 36, the cross product. This is not a common arc. You have to put it into a calculator, and this is the answer. As far as how many decimals, normally you go one more decimal than what is given. So probably you stop here is 117.6. But if you have doubts, just put as many decimals as possible. So a quick recap. This is 36 degrees. These two must add up to 180. We get 144. This one, and this one must add up to 180. We have these two. We get 18 degrees here. Because these two are identical, then the sides are identical. Isosceles triangle. This is 200, so is this one. And now this small right triangle, sine of 36 is the opposite CD over the hypotenuse, which is 200. And we find the answer. Solve the right triangle where A is 8, B is C, and capital C is 90 degrees. In other words, this is capital C, which is 90 degrees. We use lowercase to represent a side, uppercase to represent an angle. So this is A, Opposite that is lowercase a, which is 8. This is capital B. The opposite side is lowercase b. And so A is 8, B is 2, and capital C is 90 degrees. So it's a simple case of a Pythagorean theorem, a squared plus b squared equals c squared. So 8 squared and 2 squared, 68. C is square root of 68, which is 2 squared of 17 or 8.24. That's square root of 68 is square root of 4 times 17. 4 comes out as 2. This is an exact answer. So always go with the exact answer. And normally this one, as I said, this has a whole number. So it really normally goes with 1 decimal, but you follow the instruction. Now, so we have that one. So we got this side. Now, one of those angles, for example, this one tangent is the opposite B over the adjacent A. You want to use what's given, everybody, if possible. In other words, maybe we calculated this wrong, so go with the given. 2 over 8 is 1/4. So B is tan inverse of 1/4. You put it into a calculator, and it gives you 0.25 radians or 14.03 degrees. Just make sure your calculator is in a proper mode. Now, all angles add up to 180, or you can say this is 90, A plus B is also 90, subtract this from 90, and you get 75.97 degrees. And you just write the information. A, B, C, capital, those are the angles, lowercase a, b, c are the sides. And again, reminding you, if you have, it was mentioned here, if you have a right triangle like this, first Pythagorean theorem, a squared plus b squared equals c squared. Sine A is the opposite A over the hypotenuse, whereas sine B is lowercase b over c. Cosine, tangent, so we should know those properties of right triangle. So what you have here is the information about right triangle. I'm making sure you're comfortable with all of those so we can move on, everybody. A girl is standing 20 feet in front of the Disneyland Christmas tree. The star at the top of the tree to the bottom of her shoes makes a 60-degree angle. How tall is the tree? What is the distance between the girl and the star? Make sure you draw a diagram. This is a question cannot be done without the diagram and defining your variables. So here's the tree, here's the girl. At the top, we have the star, and here's the, bottom of her shoes. And it makes a 60-degree angle, so this must be the 60-degree angle. How tall is the tree? Well, we have a distance of 20 feet, okay, in front of the Disneyland Christmas tree. So we want X. And we want C. So hopefully it's clear to everybody as to what we are looking for. Well, the easiest way is to look at this and say, okay, tan of 60 is the opposite x over the adjacent tone. So very straightforward, everybody. Cross product, x becomes 20 tan of 60 degrees. And tan of 60 degrees is a common arc square root of 3. It's precisely 20 times square root of 3. Roughly, with a couple of decimals, x is 34.64 feet. A squared plus b squared equals c squared, because we know x to be this much, we can calculate the hypotenuse. Again, that's not the only way, but that's one way. So 20 squared plus 34.64 squared, you put it into a calculator, you almost get 1600, and c is 40 feet. This is very close to 1600, everybody. Find AC, angle A, angle B. So this is the given. So this side is 5. This side is 8. This angle is C. So just for the sake of argument, this is lowercase a. This is lowercase c. This is lowercase b, because capital B represent the opposite angle. So we are looking at side SS, side A angle. And we use the sine law. The sine law says the ratio of sine to opposite sides are the same. Sine of A over A, sine of B over B, and sine of C over C, they are all equal, which means you pick two of those. There are three fractions. You pick two of them, and out of those, for example, this 4, out of those 4 pieces, 3 must be known. Okay, so now we know this one, we know this one. So we have to use this two. We know this one, we don't know this one. See, this one we don't know anything about. So we have to go with this 3 and A. So sine of 67 over 8 is sine of A, which is missing, over 5, based on the sine law. A quick recap. This is what's given. 1 and 2 sides, SS, 2 sides are given with one angle. We call it SSA. Okay, everybody? The ratio of sine to the opposite side, it's equal for all sides. So that means if you do the cross product, 5 times sine 67 is 8 times sine A. So sine A becomes 5 times 67 over 8. You put that into a calculator to find the answer. Now, to do that, you put it into a calculator, and this value becomes 0.5753. So to find the A, you put it into a calculator, you say sine inverse of that, and it gives you 35.1 degrees. So all angles must add up to 180. That means this one plus this one plus the missing B, because we just found A, right? Must add up to 180. So what is B? Add these two, subtract it from 180. So by the way, case 2A is 144.9. Let me explain to you about sine law. It's a ambiguous case, and we will discuss it further in the next page. Why the case 2 is 144.9? When sine becomes 0.5753, a positive value, then sine is positive in the first and second quadrant. In the first quadrant, it is also the reference arc. In the second quadrant would be 180 minus that reference arc. So if you subtract this number from A, you get 144.9. However, this is not possible. Why not? Remember, the sum of the angles A plus B plus C must be 90, 180 for any triangle. So when you add 67 to this, it takes you beyond 180. Therefore, it doesn't work and it's out. So the reason it's impossible, because 144.9 plus 67 is larger than 180. So case number 2 fails. That's one of the reasons it's called ambiguous case, because anything could happen. All right, so we continue with that. B would be the sum of 67 and 35.1 subtracted from 180. So when we add these two, A and C, we get 102.1, subtracted from 180, we get 77.9. So we got all the angles. So if we have this one, now we can find the B using the sine law. So again, we are going to use what we were given rather than what was calculated, because what if it made a mistake in the process? So we use this part. Instead of sine A over 5, we are going to go with sine B, which is sine of 77.9 over lowercase b, or AC, which we don't have. So AC, remember AC is lowercase b. So again, the cross product. It makes AC the product of 8 and sine 77.9 degrees divided by sine of 67 degrees. You put that into a calculator, a decimal or two, and this side lowercase b or AC becomes 8.5. And let's write all of those. AC or lowercase b is 8.5, angle A is 35.1, angle B is 77.9. These are the stuff that we found, okay? So as I mentioned, SSA, side angle. So solve SSA triangle is called the ambiguous case. Side angle, we use the sine law. So here's what happens. H, if you look at this angle, sine of A is the opposite H over B. So H is the product of these two. So B times sine A. If A is less than H, which is B sine A, we don't have any answer. No triangle. If H equals B sine A is less than A and A is less than B, then it creates two triangles. It creates the large one and this one. So there are two possibilities. That's why. So you may have no answer. You may have two answers, or the previous page we had one. That's why it's called an ambiguous case. This example, solve the triangle given that A is 3, B is 2, A is 50, draw a diagram, and we are going to use SSA. And when you draw a diagram, it may not be to scale. It's okay, class, because in the beginning, we may not know what every side is. So capital A, capital B, capital C represent the, angles. Now, B opposite the lowercase b opposite capital B is 2. Uh, A opposite the capital A is 3 and A is 50 degrees. So we write this for the three angles and sides. So we get sine of 50 over 3, sine of B over 2, and sine of C over C. So obviously, we are going to use these two because everything is given except sine B. For now, we ignore the last one. So look at these two cross product gives you sine B. Sine B is 2 times sine 50 over 3. I hope everybody's okay with the cross product. Right? You put it into a calculator and sine B becomes 0.511. So what happens? Very simple. B is the sine inverse of this number. And you put it into a calculator. That means sine inverse of 0.511. 30.7 degrees. So this is case 1, and case 2 would be 180 minus this number. And 180, again, so to get this, subtract this from 180, everybody. So when you subtract this from 180, you get 149.3. Now 149.3 and 50 degrees, it goes beyond 180. That's not doable. It's not possible. So that one is out. We work on what we have. The last angle missing would be the sum of the other two subtracted from 180, because everything must add up to 180. This one and this one. 80.7 subtracted from 180, we get 99.3 degrees. So we have all the angles. Now over here, we have this one, and now this one, sine of 99.3 degrees. So we are going back to what we wrote here, and we're going to use the first one and the last. So C would be the product of these two, 3 times sine of 99.3 divided by sine of 50. Cross product, right, everybody? Putting it into a calculator gives us 3.86, and we write all of them now. A is 50 degrees, capital B is 30.7, capital C is 99.3 degrees, lowercase a is 3, B is 2, and this C is 3.86. We have all the sides as well as the angles. Try and solve the triangle where A is 8, B is C, and B is 3, and C is 6. So we use SSS, side, 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 requires the cosine. Now, we know the sine law, sine A over A, sine B over B, sine C over C are equal. Cosine law says A squared equals B squared plus C squared minus 2BC cosine A. In fact, Pythagorean theorem is a special case of a cosine law when the angle A is 90 degrees. So we are going to do a drawing. Again, it may not be to scale. A is 8, B is 3, C is 6, and those are the opposite angles, A, B, C. And so when you have this cosine law, you can move the minus 2BC cosine A to the left, make it positive, move the A squared to the right, make it negative, and then divide by 2BC to get cosine A. That is the fastest way to get to the angle. So we are going to use this formula. So B squared 9 plus C squared 36 minus A squared 64 divided by 2 times B, which is 3, C, which is 6. Is to add up to 45. Minus 64 is minus 19. 2 times 3 times 6 is 36. Negative 19 divided by 36. You have to put it into a calculator. That means A is the cosine inverse of this. And cosine inverse of a negative number puts you in the second quadrant, 121.86 degrees. You have to apply the cosine law one more time for one more angle, and then you have a choice of going with the sine or cosine. So cosine B, the same token, is a squared plus c squared minus b squared over 2ac. So look at this formula. And just this pertains to angle A. So if you change this to angle B, then it becomes a squared here and b squared here, and of course 2ac. Just plug it. In other words, you already have those in a different order. A squared is 64, plus c squared is 36, minus b squared is 9. Put the denominator 2 times 8 times 6. So 64 plus 36 minus 9 is 91. 2 times 8, 16 times 6 is 96. So B is the cosine inverse of this ratio, 91 over 96. You put it into a calculator, gives you 18.57 degrees. So let's see what we have. We have all sides. We have two angles. What would be the third one? The sum must be 180. A plus B plus C must be 180. So add up these two. Subtract it from 180. So angle C is 180 minus the sum of A and B. A and B, 140.43 degrees. Subtract it, and you get the answer. 39.57 degrees. And we write all of them, A, B, and now the C. Okay, 39.57 degrees. Lowercase a, b, c are, of course, given. What if they ask us to find the area? I remind you of a formula, area of a triangle. If the sides are given, we use Heron's formula, which says the area is the square root of s times s minus a times s minus b times s minus c. What is s? Half of the perimeter or semi-perimeter. That means a plus b plus c, all sides, divided by 2. That's why it's called half or semi-perimeter. So add them up. So we're going to add 3 and 6 and 8 and divide by 2. We get 8.5. Add up all sides. That would be the perimeter. Divide by 2 becomes the semi-perimeter or S that we need. Now we put it into this. 8.5 times 8.5 minus A, which is 8, minus B, which is 3, minus C, which is 6. And of course, you put it into a calculator. You get 58.4375 and 7.644. By the way, you don't do the rounding until the very last moment. Intermediate steps, if you do the rounding, you encounter a lot of errors. It's called just the error that it's unforced error, if you will. So you want to make sure you keep up with many decimals in your intermediate steps. Okay. We want to solve the triangle where B is 45, C is 95, and lowercase c is 5. And of course, draw a diagram. It's Again, it's really helpful if you do that, and it doesn't have to be to scale. So we have this one, this side is 5, this is 45 degrees, this is 95 degrees, and we are going to use the sine law. Side angle is given. SAA, short for side angle. So obviously, the very first thing is to find the third angle and then use the sine law. So when it's side angle, when two angles are given, it's really very easy to see. The very first step is to find the last angle. So these two add them up, subtract it from 180, and you get 40 degrees. So we have all the angles. Sine A over A, sine B over B, sine C over C. So for example, sine A over A, sine B, which is mean sine 45 over AC, and sine C, which is sine of 95 over the opposite side 5. So since we have these two, of course, we are going to put it first. These two are known. This is known. This is known now. Okay, use any of them. For example, sine of 40 over 8. So cross product will do the job. So A would be the cross product 5 times sine 40 divided by sine 95. And of course, you put it into a calculator, you find the value of A to be 3.23. That means this one. Okay, so let me just write that again. I want to make sure everybody is comfortable with that. So we have lowercase a here. Okay, lowercase b here, everybody. Now we go with the next case again. Use what you already have. You have these two. So we have sine 95 over 5, but this time 45 degrees, sine of 45 degrees over b. And again, cross product. 5 times sine 45 divided by sine 95 will give us the value of b. We put it into a calculator. B becomes 355. Now we write all of them in one shot. A is 40 degrees, B is 45 degrees, C is 95 degrees. And the sides ABC, A is found to be 3.23, B is 3.55, and C was given as 5. So we write everything in one shot, so it makes it easy to find. All right, we are going to move on. We want to solve a triangle again. A is 55 degrees, C is 20 degrees, A is 4. Draw a diagram. So you use side angle. There are two angles given, okay, and one side. So basically, just like the previous one, as far as the drawing is concerned here, that helps everybody. This is 55, this is 20, and this side is 4. So obviously we add these two, subtract it from 180. That's the fastest way to get one of them. The missing capital B is 180 minus the sum of A plus C. So 55 and 20 subtracted from 180 results in 105 degrees. Now we go with that. Sine A over A, sine B over B, sine C over C, and we write the one that we have sine of 55 over 4, now sine of 105 over B, or 20, whatever you want to put first, it makes no difference. The cross product, everybody. The cross product, 4 times sine 105 divided by sine of 55 gives you B. So we do the cross product. Now sine 55 over 4, sine 20 over C. This was given. We try to use the one that is given. Now C will be the product of these two, 4 times sine 20 divided by sine of 55. And when you put it into a calculator, it gives you 1.670. So now we are going to put everything that we have right here. So in the case of a side angle, the first thing is to find the missing angle. That's the fastest way. Subtract the sum from 180 and then use the sign. Use the law of cosines. This is the sine law, this is the cosine law, and so forth, to prove cosine A over A, cosine B over B, cosine C over C. When we add them up, we get A squared plus B squared plus C squared over 2ABC. So we want to prove that. So we have to remember, when we do the proof, we start from one side. Perhaps the left-hand side is LHS. The left-hand side is perhaps more complicated. So we are going to take a common denominator, becomes ABC. So cosine A times BC plus cosine B times AC plus cosine C times AB. So that's a simple process that we go over, and we take a common denominator. Now we look at this one, and we want to come up to this. Notice the denominator is almost there, so that's somewhat done. Now to get this, if we go back to this one, cosine of A is that. And because of the 2, which means we have a 1/2, let's multiply both sides by BC. So let's multiply both sides by BC. So if I multiply by BC, what happens? I have a BC on this side. I have a BC on this side. These two cancel each other. So I get BC cosine A on the left, I get B squared plus C squared minus A squared over number 2 only. So the denominator is 2. So if that is the case, you can go through the same process and see that for the rest of them works in the same manner. So AC cosine B is A squared plus C squared minus B squared over 2. And AB cosine C is A squared plus B squared minus C squared over 2. Okay. Again, this one we proved. The rest of them follow the same manner. So what we are going to do, we are going to replace each one of them by this. So BC cosine A by this, AC cosine B by this, AB cosine C by this. Let's do that. And what we are going to do, we are going to take a common factor of 1/2 out. All of them are 1/2 times those, right? So 1/2 times this, 1/2 times the green one, 1/2 times the yellow one. And notice what happens. So inside the brackets, B squared cancels out minus B squared. C squared cancels out minus C squared. Negative A squared cancels out positive A squared. So what's in the numerator? 1/2. We can put the 2 down here. And whatever you see here, A squared plus C squared plus B squared. Wow. A squared plus B squared plus C squared. And the denominator, this 1/2, you can put the 2 here, 2ABC, and believe it or not, that's the right-hand side, and that's the proof.